scores. Like you did well. Like so, and on a lot of hard questions. I think the problem with this test or quiz was it had a lot of different information, so it was testing too many ideas. But like for example, question 13, you should be really proud of like having done all parts of that very correctly because like when we're reviewing, you didn't even need reminders of how to do these things, and so just off of like the prior discussion and what your own like mastery, like you did great with that question, so you should be proud of yourself on a lot of questions. Okay, so now I'm on question 10, and then it's part C, so that's the fifth root of. Mm-hmm. Go ahead. Mm-hmm. So what do you think happened here? Yep. Exactly. When the index is odd, it's okay to have a negative a number inside the root. And what does this come out to? It's okay. It's okay. It's okay. It's, it's okay. What kind of a two? Yeah, exactly. -2. That's it. Like so, I'm sure like this will stick in your memory for future. So that's all. It's good. Like as long as learning is happening. Okay. So 11. So for 11, sorry. Um, like let's see. So you had the cube root. This is 11a. The cube root of 12 times the cube root of 4. So talk to me. No, there's well, okay, so yeah, like you could break it up if you so chose, but neither 3 nor 4 is a perfect cube. So the perfect cubes we know are like 1, 8, blah blah blah, right? After 8, what's the next perfect cube? Exactly, exactly. So like right now, neither of the numbers inside the root are perfect cubes, neither 12 nor 4. So in this instance, what would you want to do? What should you do since neither is a perfect cube? Uh, say a little more what you mean there. Exactly, because like you want to do that if like there's stuff added and subtracted. No worries. Now you did try to break 12 into 3 and 4 again. Since neither 3 nor 4 is a perfect cube here, the thing to do is to bring them back under the same cube root. So what would they turn into under the same cube root? Exactly. Cube root of 12 times 4, which is cube root of. Go ahead. Cube root of what? Yeah, exactly. You're right. 48. I thought it was 64, but 48 is correct. Yes, because 24 and double 24. Yes, exactly. But now we can go back in the other direction, which is 48 has a perfect cube that goes in it. What perfect cube goes into 48? Uh-uh. But it's okay. So yeah, the perfect cubes. Exactly, exactly. 1, 8, 27, yada yada. So exactly, 8 goes in. So now you want to go, oh, cube root of 8 times cube root of what? Exactly. And then the 8 comes out as a, since it's a perfect cube, as what? Exactly. So your final answer is 2 cube root of 6. Fair? Okay, cool. All right, you got it. No worries. Okay. And then B is, um, sorry, B is fourth root of, and it's fourth root of 162 x to the fifth over fourth root of 2x. Talk to me. What should we do? Yeah, it's okay. It's 27 times 6, 162? Yeah. Yeah, it's okay. This time, yeah, instead of perfect cubes, what are you looking for? Perfect fourth powers, right? Yeah, and so um, one thing you could do again is just put them under the same fourth, the same root, fourth root, and so it would be. So I'll just tell you, sorry, 162 x to the fifth, and then over 2x, and then here you can simplify. How exactly? Well, this x and this x to the fifth would turn into what in the numerator? That's right, x to the fourth in the numerator. And then the 2 and the 162 would cancel to what? Exactly. Now, both 81 and x to the fourth are perfect fourth powers. So you have the fourth root of, and then it's 81 x to the fourth. Got it. So then this comes out very clean into a what? What's the fourth root of 81? It's okay. Huh? 3? And then? It's okay. And then? What about the fourth root of x to the fourth? That would just be x. Okay, it's okay. No worries. Good. So you could do this. Another option, and I'll just do it. So we can be efficient. Another option is like right where they're at in the numerator. You could try to break it up like this. So you could be like the fourth root of 81, and then the fourth root of 2. That's the 162 split into 81 and 2, and then the fourth root of x to the fourth, and then the fourth root of x. That way, x to the fourth and x make x to the fifth. And then the denominator, you wouldn't do anything. You would just keep it and be like the fourth root of 2, and then the fourth root of x. Now, look here. So we split the denominator also into these two parts. Although neither of them is a perfect cube, now what you could do is you see identical things, numerator and denominator. There and here. So the only thing left is in the numerator you have the fourth root of 81, which we know is 3, and then also the fourth root of x to the fourth, which we know is x, so getting you to the same place as here, 3x. Fair? Right. Okay, cool. All right, so you had those two options there, and then yeah, so in part C, you did great. It's what is it that she's pointing out? Exactly. So you just needed like yeah, exactly. What you did was correct. You just needed an x outside. That's all. Um, okay. So it's x outside, and then cube root of x. Good. Okay. Next is, this is the one where you want like terms. This is the yeah, it's okay. Cube root of 24. Let's see. X cubed, y cubed, um, plus xy, and then cube root of 81. Okay, cool. So talk to me.
So I guess the first part, I'm assuming I did it right, except
You
it's
did.
not the
Yeah, you did, exactly. So, like, you saw that x cubed and y cubed can come out as just an x times y, so that's great. And also, like, she should reward, like, some partial credit for this, but it's okay. And then you have the cube root of 24. And then in the second part, you have xy, and since it's cube root, 81 is a perfect fourth power, but since we want cube root, how should we split 81?
um,
Yeah,
so um, that's 27 times 3.
exactly. Cube root of 27, and then times cube root of 3. Now, the 24 also, we can break up so that it involves a perfect cube. How is that?
Um, the 27. So you're saying 27 is divisible by something else?
So, or sorry, not the 27. Sorry, I think I misspoke if I said 27. This 27 we know is going to be a 3. It's a perfect cube. But the 24 right here, we had written a cube root of 24 here. Well, 24 isn't a perfect cube, but there's a perfect cube that goes into 24. What's that?
Oh, 24, not
Mm-hmm.
27.
Mm-hmm.
So 8.
Exactly. So we want to be like with the 24, we want to be like cube root of 8 times cube root of who?
Um,
Exactly. And now you're happy because there's a cube root of 3 here and there's a cube root of 3 here. The cube root of 8 comes out to a 2, right? And so you have 2xy cube root of 3 plus the cube root of 27 is 3, so you have 3xy cube root of 3. Now what?
yeah, you can treat them as variables, right?
Exactly. Exactly. So how do they combine?
5xy cube root of 3.
There you go. 5xy cube root of 3. Great. Good job. You're very welcome, kiddo. Okay. All right. Sorry. And then next one is um, so I guess on the next one, like the only mistake is that she said that you had a 3 at the end. That should be a different number. I'm sure if you were given more time, you could figure out what that's got to be. And I don't see what's wrong with a cubic polynomial. Cubic polynomial is correct. Like I guess she's saying like it's a trinomial, and maybe the 3 is supposed to cancel because if it's a trinomial, obviously with the 3 it would have 4 terms. But like you should ask her like what's wrong with cubic polynomial because it is a cubic polynomial. Um, yeah. So okay. All right. So we don't need to discuss that. But again, like yeah, keep track of your negatives. You'll see how they should cancel. Okay. Now the 15a, that's x cubed plus 27, and so this is the sum of cubes. It's a cubed plus b cubed, and
Yeah.
yeah, no worries. You had it almost. It's okay. A plus b times a squared, and then it's minus ab, the middle, and then it's plus b squared here. The only thing missing was that she changed that into a plus as it should be, and that's all. Otherwise, you did well on this question. No worries. So this is A. Mm-hmm. And then on B, it says 16x cubed and then minus 128. Okay, talk to me. So actually, you did the hardest part right, which is you saw that you should take out a greatest common factor, 16, and then it's x cubed minus 8 here. Talk to me from here.
Um, okay, so I guess from there, um, since I guess I'm looking at what she wrote. I don't really get it.
It's okay. So this time she's saying that we should use the difference of cubes formula on this part. And that's the a cubed minus b cubed. What is that?
Um, like the A plus.
Yeah,
Well,
it's like that. Uh-huh, go ahead, sorry.
um, I guess I know it's what it would be switched.
Exactly. It would be a minus b, and then it's a square, and then plus ab plus b square. And so, um, and we would write 16, and then you have x cubed, which is, well, so the 8 is 2 cubed, so it's the a is x, and then the b is 2. Fair?
Yeah.
Okay, so we would go, talk to me, you talk.
Um, so if the A is S and the B is 2, then it would be x minus 2
Yep,
times x squared
yep.
minus x times 2, which is 2x,
Mm-hmm.
plus x squared, which is 4.
Mm-hmm. Okay, great. And but what's the sign right here before the 2x?
Is it still a minus?
It's a plus.
Oh, no, I said plus. I thought
Okay.
two.
Okay, it's okay. Don't worry. Don't worry. Yeah. So it's for future. Like if this comes up again, we will. I'm sure you memorize these two. These two formulas are important, but otherwise you're good. Okay. All right. So that's that. And um, sorry. And then finally the last page. Um, so like um, this is the one I looked at very quickly, but it says you're asked to completely factor 6x squared, okay? 6x squared, and then plus 12x minus 18. Got it. And it says then the completely factor solution is, okay, 6x, no, 6x minus 6 times x plus 3, okay? Well, how would you check if this is the correct factoring, first of all?
Well, I mean, that's the very common factor.
Yeah, like, yeah, sorry, go ahead.
Then from there, I guess I needed two numbers that multiply to negative 3 and add to positive 2.
Yep, and what are those?
I thought they were 1 and, I mean, negative 1 and 3.
I agree. So it would be 6 times x minus 1 and then x plus 3. Obviously, you could have the x plus 3 first and then the x minus 1 after it, and that's a different way of writing it, but this is the correct factoring. So let's see. In here, it says complete factor. Well, it's not completely factored because, well, while the x plus 3's match, from the 6x minus 6, we could have taken out a 6. So as to write 6 times x minus 1 and then x plus 3, right?
Yeah.
Yeah, so what's the point that's being made here?
I guess that even though it is like a correct way to write it, not fully simplified.
Exactly. Basically, the 6 is not factored out of this group, is the point that she's making there. Okay, cool. So here, I do love math. I don't know about math class now. Here in 6, like she's talking about union and intersection, and we didn't get a chance to discuss this. Were you not told that it was going to be on the quiz?
I mean, I honestly, this like sense and stuff we went over so briefly that I did not think it was like, I wasn't even thinking about it. Like,
Okay, no problem.
He barely spent any time going over it. Like, I'm honestly surprised she even put it on this.
No
But
problem. It's okay. So, what is the intersection A intersect B? What is that?
I have
Huh?
I completely guessed on me, but I have no clue.
Okay, no problem. So A intersect B is the elements. So like when you have a set, like so, the first set A is I love. So each letter is called a member. So and the intersection are the members of the two sets that are the same. So what is the same in both sets? Is there any element that both sets contain?
Well, well, L. Yeah.
Yeah, let's see, math class L, and then is there any other one?
Um,
Not that I see.
no, no.
No. So then A intersect B would it just been the letter L?
Okay.
Okay, that's A. And then A and for B, A union B is like so A union B is everything in both sets but without double counting. For example, they both have L, so you're not gonna write two L's. You're just gonna write one L. But basically it's whatever is in one set and whatever is in the other set, and if they have anything in common, you don't write it twice. So this
Okay.
yeah, exactly. So tell me what you think this would be.
So, it would, I guess, it was the same one I love math, and then for class, you take out the L and one of the S's.
Yes, yeah, like that's weird that she has two S's. Well, we would. It's kind of strange. You don't ever write like the same element twice. So that's actually I think a mistake on her part. But I suppose like if you were answering this question like assuming that the she's talking about two different S's, you would keep two S's. But what you said just now is perfect. Yes, you don't write anything twice unless like one of the sets oddly has um, the item twice. But you answered it correctly. I don't even need to write. Okay, cool. And A intersect B, like it's possible. Like suppose that L wasn't common to both, so they had no common elements. Then you would write this, which is the empty set. If in the intersection, neither of them has anything in common. And the union, you won't ever get the in this you won't ever get an empty set because well unless both of the sets are empty sets, then there's bound to be something in one or the other. Make sense? Okay, cool. And then 77, you did great on the first one. Now, on the second one, like it's a slightly tricky idea, but don't worry. Like, so, like if I ask you for the absolute value of -7, what's that? Yeah, and obviously the absolute value of +7 is just 7. So the absolute value is the negative of u. So this is what I can say. I can say that if you're a negative number like -7, your absolute value is the negative of whatever is inside. So like -7, which is +7. Does that make sense?
Yeah.
Yeah, so what you need to do in an absolute value question is look at what's inside, decide if what's inside is negative or positive. If it's negative, then you take the negative of it, which is you throw a negative sign in front of it. Now, when you're looking at the absolute value of pi minus 4, what is pi approximately? Exactly. So is the number pi minus 4 negative or positive?
Negative.
Exactly, because 4 is bigger than pi. So then, just like we did with the 7, you take what's inside, which is pi minus 4 this time, and then since it's like more than one item, you take the negative of it, which is you throw a negative in front of it. But when you do that, it's going to be negative pi plus 4, which you can write as 4 minus pi or just negative pi plus 4. But basically, you look at what's inside and decide if it's negative or positive. If it's negative, then you throw a negative in front of it. Does that make sense?
Yeah.
Okay, cool. All right, so this one was like the slightly somewhat